Here's the solution for day 2, problem 1. The polygon is graphed below. It is reflected over the line y equals 2. Graph the image, and then it asks, what are the coordinates of point A prime? So we want to find the line y equals 2. So here's the origin, here's 1, and here's 2 on the y-axis. The line y equals 2 is a horizontal line crossing 2 on the y-axis. This is our reflection line. What that means is we're going to take this polygon and redraw it on the other side of the reflection line. Now a reflection is a rigid motion that retains distances. So the way that we can draw this is to find the distances between the vertices of this shape and then duplicate those distances on the other side of the reflection line. For example, point A is 1 unit above the line y equals 2. So if we continue 1 unit below the line y equals 2, this is where the image of point A is located. And it's common to call that A prime, where this little apostrophe mark is the word prime in geometry. We can do this for the other corners of the shape as well. Point W is 2 units above the line y equals 2. So let's continue 2 units to the other side of the line y equals 2 to find its image, called W prime. Point M is 3 units from the line y equals 2. So let's go 3 units to the other side of the line to find its image, M prime. Notice that M and W are only 1 unit apart in the original figure, and in the image they're also 1 unit apart, because reflections are rigid motions that retain distances. Okay, we have one more corner to locate. Here's point D, and it is 3 units from y equals 2. So let's travel 3 units to the other side of y equals 2 to find its image, D prime. We can then connect these dots together to create our polygon. Notice that this is the same size and shape as the original image, but it is its mirror image over the reflection line y equals 2. That takes care of question A. Now question B, what are the coordinates of point A prime? Point A prime is located right here. This spot is the origin, so it is 1, 2, 3, 4 to the right and up 1. It is located at 4, 1. Now day 2, problem 2. Triangles are drawn below and congruent parts are marked. So here we have the top triangle. Notice that this angle has a little loop in it. In the bottom triangle there is an angle that has that same style loop. That indicates that this angle is congruent to this angle. They're the same measure. This angle here has a double loop in it, and this angle here in the bottom triangle has a double loop in it. These are the same size. Question A, are the triangles congruent? And then in question B, if yes, we're asked to identify the postulate or theorem used as the justification. So the idea here is there enough information shown in the picture for us to know for sure that the triangles are congruent? We have a pair of angles congruent to a pair of angles in the other triangle, and even though there's no mark on it, these triangles share this side. I'm actually going to put a mark on it, just a little X symbol. In the top triangle, we have 2 angles and the included side between the angles congruent to 2 angles and the included side in the other triangle. So yes, that is enough to know for sure that the triangles are congruent. And in part B, our postulate is called the angle side angle postulate. The abbreviation that we're going to use this year in geometry class for angle side angle is ASA. What the angle side angle postulate states is that if a triangle has 2 angles and the side included between the angles congruent to 2 angles and the side between in another triangle, then the triangles are congruent. And that is the situation that we have in this picture.